So we're just going to finish up this adding and subtracting section. Now we're still going to be adding and subtracting these rational expressions, so these fractions. We are going to add in now where we want to also state any values that x cannot be, because it would cause the expression to become undefined. You guys did that with multiplying and dividing, where you had to look at like the bottom of the fraction when it was factored out, and you had to either like set those pieces that you had equal to 0, or you just had to kind of think mentally to yourself, what numbers, if I put it in for x, would cause there to be a 0 in the denominator, so that if I have a 0 in the denominator, I can't actually do that. I can't divide by 0. That's an undefined type function there. Like if you do that on your calculator will not do it for you. It'll give you an undefined or an error message of some sort. So we also are just going to kind of add that piece in now, but we're still going to be doing the same thing that we did yesterday. So if we don't have common denominators, we'll have to get common denominators. And then we'll talk about at the very end what values can x not equal, because it would cause the entire thing to become undefined. For this first one, I have common denominators because they both are over x plus 4. So I don't really need to do any multiplying by anything for this one because they're already like each other. So we can go ahead and simplify. So I'm just going to keep it over x plus 4. So now in the numerator, you have to add your like terms. So what's x plus x? 2x. And then what's negative 3 plus negative 2? Good, negative 5. So we have 2x minus 5. Now I'm not going to be able to simplify that at all because I can't take a 2 out of both 2 and 5. So this is going to be my simplified answer, but I also need to include now what numbers x cannot equal. There's only one quantity in the denominator, which is at x plus 4. So if you think about setting that equal to 0, if I subtract 4, I get negative 4. So that's what would cause it to be equal to 0 on the bottom. So that means x cannot equal negative 4 for this problem. Like I said, you guys did this for multiplying and dividing as well, where you had to find those undefined values. Okay, so let's take a look at this next one here. So we have x over x plus 2 minus 8 over x squared minus 4. Which denominator do we need to factor? First fraction, second fraction, which one? Second one? Because the second one says x squared minus 4, we need to try to factor this a little bit. This is a difference of two squares. We saw this yesterday and we saw this the day before. What's the square root of 4? 2. Do you guys remember what your signs have to be? Good. One has to be plus, one has to be minus. So from the first fraction, what do we need to add to it? Or yeah, the x minus 2. So for that first fraction, I'm going to take times an x minus 2. We're not going to do anything to the second one. On that first one, you have to take x times x, and then x times the negative 2. So on top now, it's going to say x squared minus 2x. And this is over x plus 2, x minus 2. And then we're going to subtract 8 over x plus 2, x minus 2. Now that your denominators are the same, we can simplify the numerator. Now if you look at the terms on top, you have an x squared, a negative 2x, and then it says minus 8. You can't really combine any of those because they're all different. So we're just going to write it out as a new expression. It's just going to say x squared minus 2x minus 8 over that x plus 2, x minus 2. Let's try to factor the top. So I'm going to go ahead and put an x in each one. Think about two numbers here that would multiply to a negative 8 and they would add to a negative 2. Good, negative 4 and 2. So we're going to have negative 4, so minus 4, and then we're going to have plus 2. Is there anything that we could reduce? Good, x plus 2's can go away. And so we're going to be left with x minus 4 over x minus 2. Now we have to talk about what values x cannot equal. So we're just kind of adding this piece on now. Now you want to make sure that you go back to the original denominator, okay, not the simplified one. So the original denominator comes from like up here. We saw a lot of this x plus 2, x minus 2. What x values would cause them to become zeros? There's two numbers out there. Good, negative 2 and positive 2. Because if I take negative 2 plus 2, I get 0. And if I take 2 minus 2, I get 0. So x cannot equal positive or negative 2. So I'm just going to write that as plus minus 2. Now you could separate it. You could say 2 and then comma negative 2 if you wanted to keep them separated out. That's fine. All right, I want you guys to try number 3 on this page. Okay, so for this one, this second fraction here, when you see x plus 3, the quantity is squared. It's a little bit different than what we saw in that last one. That last one said x squared minus a number. This one doesn't say x squared plus 3. It says the whole thing is squared. That means that there's actually two of them. So it's the same thing as x plus 3 times x plus 3, like that. So that means that the first one is missing an x plus 3. Okay, so we're going to take that first fraction times x plus 3. Oops, and we're not going to do anything to the second one. We're going to leave that alone. But I am going to write it out as x plus 3 times x plus 3 now. Okay, for this first one, when you guys distribute the x, what does it say on top now? Good, x squared plus 3x. Okay, so now if we simplify our numerators, what does it say on the top when you combine like terms? Okay, very good. Now let's try to factor the top. What two numbers can multiply to a 6, but they add to a 5? Good, so we should have written x plus 3 times x plus 2, and this is still over x plus 3 times x plus 3. So what were we able to cross off? Good, an x plus 3. So we're left with just x plus 2 over x plus 3. What values can x not equal? Good, just -3 for this one, because the denominator originally was x plus 3, x plus 3. It's the same thing twice. So if I put a -3 in for either one, or both, I'm going to get 0 in the denominator. Okay, let's turn the page over here. Okay, if we look at this one, both of the denominators are different. We have a 2x plus 5, and then we have a 5x minus 2. So we're going to have to change both fractions for this problem. Okay, what are we going to take that first fraction times? What are we going to take the first fraction times? Good, 5x minus 2. What are we going to take the second fraction times? Good, 2x plus 5. Okay, on the top, for this first one, you're going to have to use your FOIL rules. Okay, first, outside, inside, last. So first would be 3x times 5x. What's that going to give me? Good. Outside would be 3x times a -2, which is going to be -6x. Inside is going to be -2 times 5x. That's a -10x. For the last term, you have -2 times -2. What's that going to be? Good, plus 4. Now, my common denominator, I have 2x plus 5, 5x minus 2. Now, the second fraction, you don't have to FOIL on the top, you just have to distribute that 2. So a little bit simpler here. If I distribute the 2 on the top, what's it going to say now? Good. 4x plus 10. Okay, let's go ahead and try to combine our numerators here. So I don't see any other x squared terms. I just see 15x squared. All right, let's talk about our x terms. We have a negative 6x minus 10x. So we're at negative 16x. And then we're going to subtract 4 more. So we're at how much now? Negative 20, right? Because we're going more negative. And now my numbers, what would be 4 minus 10? Good, negative 6. Okay, at this point, what I would try to do is factor the top if I can. Which this is going to be one of those problems that takes me a little bit longer to factor. So, let me just see if I can, factor it real quick here. So I'm going to take 15 times negative 6, which is negative 90. And then my b is negative 20. I'm not sure if it's factorable, because I'm not finding any numbers that work here. I don't think we're going to be able to factor this one, because I'm trying multiple numbers to get to, like, there's lots of numbers that multiply to negative 20 or negative 90, but I can't find any of them that would also add to a negative 20. So I don't believe we can factor this at all. So I'm just going to leave it here, but I need to include the values that x cannot equal. So you have to set both of those pieces in the denominator equal to 0. Now, if you can't do that mentally in your head, then I would just work it out like on the side somewhere. So we have this 2x plus 5. We're setting that equal to 0. So I would subtract 5. So I have 2x equals negative 5, and then divide by 2. So one of them is going to be negative 5 over 2. And then, for the second one, it's 5x minus 2 equals 0. So we add 2. And then we divide by 5. So we're going to get 2/5 for the second one. The last examples I want to show you here in this section is when you have a fraction over another fraction. They're called complex fractions. And what we're going to do is rewrite it as a multiplication problem. And then we're going to go back and kind of use some of our multiplying and dividing. So we're kind of stepping away from adding and subtracting for just a minute here. And we're going back to multiplying and dividing. So you'll see something that looks like this. So on top, you have x plus 2 over x minus 1, and that's being divided by x minus 3 over x plus 5. It's called a complex fraction because there's fractions inside of a fraction here. Okay, so when you see something like this, you're going to want to rewrite it as a multiplication problem. The piece in the numerator, so the piece up here in the top, you're not going to do anything to that. So I would just rewrite that down here below. So it's going to be x plus 2 over x minus 1. I'm going to change this from a division problem, because remember, fractions represent division, to a multiplication problem. Now remember when you guys were changing multiplication or division problems to multiplication problems, what did you guys have to do to the fraction on the bottom? Flip it. Okay, so you're going to have to flip this bottom fraction, the one that I highlighted in blue there, upside down. So x plus 5 is going to go on top, and x minus 3 is going to go on the bottom, like that. Okay, now when I multiply here, I'm not going to actually FOIL. I'm just going to leave them as the factored quantities. So I'm just going to write it as x plus 2 times x plus 5, and put that over x minus 1, x minus 3. Okay, and the only reason why I would do that is because if I needed to do other things to this, or in another problem, if I could simplify, I would at this point. I would cross off anything that they have in common. Okay, so this one we're going to go ahead and leave right there, because there's nothing that I can cross off. So if you guys look at number 2, can you tell me first how to rewrite it so it's a multiplication problem now? Good. Okay, we're multiplying. We're not adding and subtracting, so we do not need common denominators. But it might be helpful for us to factor the denominators just so we can see if there's anything that we can cross off. You probably can't do anything to the second fraction because it's just over x. But how can we factor the bottom of the first fraction? Square root them. Okay, so this is like the difference of squares problem again. What's the square root of 1? Good, so you're going to have positive 1, negative 1. And this is times an x minus 1 over x. Can we cross off anything? So the x plus 1s are gone. Anything else? The x minus 1s are gone as well. What's left on top? Because I crossed off both things on top. 1. It is not a 0. Okay? Just because you crossed them off doesn't mean that it became a 0 on top. There's still a 1, because remember, anything divided by itself is 1. So these became 1s up here. What's left on the bottom? X. So our answer is 1 over x.